sklearn, model selection, leave one out. Description: Leave one out is a cross-validation strategy that partitions the data into a single training set and a single testing set. In each iteration, one data point is held out for testing, and the remaining data points are used for training. This approach is especially useful when you have a limited dataset and want to assess the model's performance with minimal data leakage. Inputs: None. Leave one out doesn't take any specific input parameters. Outputs: Generator: It generates a series of train test splits. Each split consists of two indices. Train indices: indices of the data points used for training. Test indices: indices of the data point held out for testing. Steps: For each data point in the dataset, the data point is marked as the test set. All other data points are used as the training set. The indices for the train and test sets are returned. Metrics: Accuracy: It is the proportion of correctly classified instances. Precision: It measures the proportion of correctly classified positive instances. Recall: It measures the proportion of true positive instances correctly identified. F1 score: It is the harmonic mean of precision and recall. Visualization plots: Learning curve plots the model's performance, e.g. accuracy, as the number of training samples increases. This helps identify if the model is underfitting or overfitting. Confusion matrix visualizes the classification performance of the model by showing the number of true positive, false positive, true negative, and false negative predictions. Fine-tune parameters: None. Leave one out doesn't have any tunable parameters. Uncertainty methods: Bootstrap aggregating bagging: It trains multiple models on different random subsets of training data and combines their predictions to estimate the uncertainty. Bayesian inference: It uses a probabilistic approach to estimate the model parameters and their uncertainty. Challenges and fixes: Challenge 1: High variance in performance estimates due to the small size of the training set in each fold. Sample use case: When dealing with a dataset of 100 instances, leave one out might result in highly variable performance estimates across different folds. Fixes: Use a larger dataset if possible. Consider other cross-validation strategies like k-fold cross-validation with a larger k-value. Challenge 2: Computationally expensive for large datasets. Sample use case: With a dataset of 1 million instances, leave one out would require 1 million training iterations, leading to significant computational time. Fixes: Use a smaller cross-validation strategy like k-fold with a smaller k-value. Utilize parallel processing techniques to speed up the training process. Explore more efficient algorithms or models that can handle large datasets more effectively.